RAM, random access memory. Definition: the RAM family. A RAM is a volatile chip memory in which both read and write operations can be performed. A memory unit is a collection of storage cells together with associated circuits needed to transfer information. It is also called read-write memory RWM. The RAM family. It has an address input lines to access 2 to the power of n memory locations and m data lines to write/read data from/ to memory. The n-bit address is placed in memory address register marked to select one of the 2 to the power of n memory location. The control signal is used to enable the read and write operations. When read signal is asserted, then the data from memory location gets selected by n-bit address then placed in memory buffer register, which is a m-bit register. Block diagram: address in bits 1 RAM memory A. R2 to the power of n-1 read MBR. 1 RAM array M A R 2 to the power of n-1 read MBR M data lines write D0 DM1. The RAM family. RAM bipolar MOS static RAM dynamic RAM static. Semiconductor RAMs may be static or dynamic. Types of RAM. Semiconductor RAMs may be static or dynamic. Static RAM uses bipolar or MOS flip-flops. Dynamic RAMs MOSFETs and capacitors which store data. A static RAM contains an array of flip-flop, one for each stored bit. Data written in the flip-flop remains as long as the DC power is maintained. The capacity of RAM varies from 64 bits to 1 megabit. The cells is selected by high value on the row and column lines. Static RAM cell. The cells is selected by high value on the row and column lines. The input data bit 1 or 0, is written into the cell by setting the flip-flop for a 1 and resetting the flip-flop for a 0 when read/write line is low. When the read/write line is high, the flip-flop is unaffected. Then the stored data is gated to the data out line, logic diagram. Data out, column, row, and S, and R. Data in, read/write. The flip-flops in the static memory cell can be constructed using a bipolar junction transistor, B MOSFETs, bipolar static RAM. IT consists of 2 transistors Q1, Q2 that are cross-coupled to form a flip-flop. Here each transistor has 3 emitters, viz. 1 row select input, 2 column select input, 3 write input. Here there are 4 transistors Q1, Q2, Q3, Q4. To select the cell, both the row and column select must be held high. When selected, a data bit can be stored in the cell or the content of the cell can be read. If either row or column select lines is low, then the memory cell is disabled. MOS static RAM. Here there are 4 transistors Q1, Q2, Q3, Q4. Out of which Q1 and Q2 acts like switches while Q3 and Q4 acts like active load resistor. The transistor Q1 conducts and Q2 remains in cutoff. Basic structure of a static RAM. RAM has address inputs, data inputs, and a read/write control. When read/write is high and chip select CS is low, 4 data bits from the selected address appears on the data output. When read/write is low, the 4 data bits that are applied to the data inputs are stored at the selected address. Logic diagram for a 256x4 static RAM. Address input 256 by 4. Static RAM Y1. Y2, Y3, Y4. Data output. Data input. RW. N. A 1024-bit device with a 256 by 4 organization implies that there are 256 rows and 4 columns. Here the memory cells are arranged in an array of 32 by 32 matrix. Operation. IT has 8 input lines A0, I7. 5 of the 8 address lines, A0 through A4, are decoded by the row decoder to select one of the 32 rows. The remaining 3 address lines, A5 through A7, are used by the column decoder to select 4 of 32 columns. In read mode, the output buffer are enabled and the 4-bit from the selected memory location appears on the output Y1, Y2, Y3, Y4. In write mode, the input data buffer are enabled and the 4-bit are routed through input data selector for storage. During read and write the chip select, that is the enable, must be low. D4, D1. Input buffer. Row decoder. A0, I7. 32 by 32 memory cell array. RW. Output column decoder. CS. Basis structure of 256 by 4 static RAM. Y4, Y3, Y2, Y1. Static RAM IC 7489 64-bit static RAM. IT is arranged as 16 words of 4-bit each. Data can be written into the memory with the help of data inputs by giving an address to the select input and holding both the enable and write low. Data can be read from any memory location by giving the address to the select input and holding the enable low while the write enable high. Advantages. The operation is straightforward and hence easy to understand. Pin diagram. VCC select inputs data sense. Input 4 output 4 input 3 output 3. 10. 16. 15. 14. 12. 11. 9. 13. BCD D4 S4 D3. S3. MIWI D1 S1 D2 S2. 1 2 3 4 5 6 7 8. Select memory data sense GND. Input A enable input 1 output 1 input 2 output 2. IC 21114 to 4K bit static RAM. It is a 4096 cell organized as 1024 by 4 bit available in a single PINIC. The accuses in-channel silicon gate MOS transistor in a static arrangement. The CS line allows selection of the expanded memory size. The WI selects BW read and write operations. The 4 data pins acts as input lines on a write operation, and as output line on a read operation. Pin configuration. I6. A5. A4. A3. A0. A1. A2. CS. GND. 10. 11. 12. 13. 14. 15. 16. 17. 18. VCC. I7. A8. A9. Y1. Y2. Y3. Y4. WI. 1. 2. 4. 5. 6. 7. 8. 9. 3. IC 2114 RAM. TMS 4016 2 KB static MOS RAM, it is byte organized static RAM. There are 11 address inputs to select 2048 locations. The data in, DY1 through DY8, are bidirectional terminals. These terminals provide both data input during write operation and data output during read operation. Truth Table of TMS 4016. WR. CS. Road. DY1 DY8. Mode. X. Data input. Write. 1. Data output. Read. High impedance. Device disabled. Output disabled. Dynamic RAM. The Dynamic Random Access Memory, DRAM, is the lowest cost, high density RAM available. It can store binary information in the form of electric charges on the capacitors. Data that is stored as charge in the capacitors must be recharged as many number of times as possible in order to retain the stored charges. DRAM makes use of MOS capacitors as memory cell instead of flip-flops. Advantages: very large memory array can be constructed at a lower cost. It offers reduced power consumption and larger storage capacity. Disadvantages: MOS capacitor cannot hold the stored charge over an extended period of time. It has to be refreshed every few seconds. The circuit becomes complex. The memory cell requires read and write GATN to operate the cell. Dynamic MOS RAM cell. A DRAM consists of an array of memory cells. In this type of cell, the transistor acts as a switch. The memory cell requires read and write GATN to operate the cell. Column/sense lines. Row/control line. Storage capacitor. Pseudostatic RAM, SRAM. IT is a dynamic RAM with a built-in refresh logic. It can be used even as a static RAM because no external refreshing circuit is required. When it is performing internal refresh, it cannot be accessed for read and write operation.